Okay, section A.4b, simplifying expressions. So simplifying expressions using the field properties of real numbers and properties of equality to justify simplification and solution. Okay, some things to remember when you're simplifying expressions. So we're still using order of operations. We're also distributing using the commutative property to rearrange things or move things around. And the purpose usually of moving stuff around is to then combine like terms. So like terms, remember, they're very specific. So any constants or numbers without a variable attached can be combined. So -7, 10, 80, those are all like terms. Those could be combined. And then if you had x or 4x or -20x, those are all like terms because they're all x to the first power. Or you might have y squared, 5y squared, -8y squared. Okay, and because they're all squared, those are like terms. So they have to have the same index, which is the number up here that tells us what power they're raised to. So n to the fourth power, 8 times n to the fourth power. Those are like terms. Okay, but you cannot combine anything that's not a like term. So constants and numbers cannot be combined with variables. And variables have to be raised to the same power in order to be combined. And also you can't combine two different variables, so a and b can't be combined. But a and a would be 2a. Okay, first example, simplify. So in this case, because there's different terms, not like terms, inside the parentheses, we're just going to go ahead and distribute. We don't need to combine. So I'm going to bring down the -4x. -3 gets distributed to the 5 and to the 2x. So -3 times 5 is -15. And -3 times 2x is -6x. And now, like I said earlier, we're going to use the commutative property to rewrite this. So the commutative property allows me to switch these. So -4x minus 6x minus 15. And the reason I can do that is because technically that is the same thing as -15 plus -6x. So because of the commutative property of addition, I can flip them around, and then it's easier to combine my like terms. So now I have -4x minus 6x is -10x minus 15. And that would be all the way simplified. That's as far as you can go. Alright, example 2. In this case, there's sort of two ways that you could do it, and both are acceptable. So because 5 and 7 can be combined because they're like terms, technically you can just add them together and then multiply. You don't have to distribute. So we get -3w times 5 plus 7 is 12. And then it just becomes -3 times 12 is -36w. Now let's say that you did distribute from the beginning. So you got -15w plus -21w. Well, -15 and -21 is -36. So either way, you get the right answer. Okay, that's why the distributive property works. So it's sort of up to you which approach you want to use. Okay, simplify again. So this time we don't need to distribute, we don't need to combine anything in parentheses, but we do need to combine like terms. So again, only if they have the same index, meaning they're raised to the same power, can we combine them. So n cubed plus n cubed is 2n cubed. N squared plus n squared is 2n squared. N plus n is 2n, and then 1 plus 1 is 2. And that would be all the way simplified because you can't combine any more terms. N cubes are separate from n squareds, are separate from n's, are separate from constants. Okay, example 4. So remember, part of this is being able to justify what we're doing. So what property allows us to move things around or allows us to solve the way we do. So it says, which property of real numbers was used to rewrite this expression as this expression? So if you notice, remember I told you you could do it either way you want, but given the steps that they've taken, they have used the distributive property. So that's all we're looking for. So the distributive property is what allows them to rewrite it like that. Okay, which property describes how this expression is related to this expression? It looks like a lot, but if you take a second to look, you'll notice that what's changed is the order. So in the first one, you have 6x plus x minus 7 plus 3x. And then all of a sudden, x minus 7 gets moved to the front, and you have x minus 7 plus 6x plus 3x. So because order is changing, that's the commutative property of addition. And remember, we have the commutative property of addition, and we also have the commutative property of multiplication. Alright, last example. Which property justifies rewriting 4n minus 7 as 4 minus 7 times n? Now, when you first see this, this looks a little bit backwards, because it is. Normally, we would write it as n times 4 minus 7. And instead, they've put the n on the other side. But either way, it's still the distributive property. Okay, so in this case, they've just sort of taken the n out instead of putting it in. Either way, it's still being distributed. Some people are tempted to say commutative property, which I would agree with here. If you're going from this expression to this expression, but since we don't actually have that listed, it's going to be the distributive property. But just so you know, even though we normally write the distributive property like this one's okay because they're being multiplied and we're allowed to use the commutative property. Okay, so but the actual answer would be distributive. Alright, and that's it for this section.